For today, we're going to start with a quick reminder of the multiplication of binomials that we were doing last week. For example, if I have x plus 6 times x plus 4, and some of you were using the FOIL method and some were using the box method, I'm going to do one of these with boxes just to remind you. So when we do it with boxes, this is a binomial times a binomial, so I need 2 boxes and 2 boxes. I'm multiplying x plus 6 times x plus 4. And again, it never mattered which one you put where. And then in each box, I multiply x times x to get x squared. I multiply x times 4 to get 4x. 6 times x and 6 times 4. These are the 4 terms that I get when I multiply each of the terms in the first binomial by each of the terms in the second. Then I need to combine my like terms to get my answer. I have x squared. The 4x and 6x are like terms, so I add 4 plus 6 to get 10x. And then I have positive 24. There are a couple other multiplication problems that are already done out here. And what we're going to do is we're going to look at some patterns, because today we're going to start going in the opposite direction. So if I look at each of these, this is the product. It's what I get when I multiply. And these are the factors. They're what I start multiplying. So if I look at each of these, there is a relationship between the constant in each of the products and the numbers that are in the factors. 6 and 4 gives me 24. 3 and 1 gives me 3. Negative 5 and negative 4 gives me 20. Negative 6 and negative 3 gives me 18. What we see is that this constant is always the product. I multiply 6 times 4 to get 24. 3 times 1 to get 3. Negative 5 times negative 4 to get positive 20. Negative 6 times negative 3 to get positive 18. There's also a pattern if we look at the number that's multiplying x, the coefficient of x. That number, 10, is 6 plus 4. 4 is 3 plus 1. Negative 9 is negative 5 plus negative 4. Negative 9 is negative 6 plus negative 3. These patterns are what we're going to use so that we can go back in the other direction. The numbers in the factored form are related to the coefficient of x because they add to the coefficient. The numbers in the factored form are related to the constant because they always multiply to the constant. So what we were doing last week was starting with this factored form, and the directions said multiply. What we're going to do today is start with this product and go in the other direction, and the directions for that are to factor. We were factoring GCF. This is called factoring a trinomial, starting with a trinomial and going back to this product. Here are the steps. If we have x squared plus bx plus c, and you'll notice for the next couple of days, it's always going to be plus c. What do we need to do? We need to list the factors of c, the numbers that multiply to c. We're going to find the pair of factors that add to b. They multiply to the constant and add to the coefficient of x. Then we write the factored form as the product of 2 binomials, where there's an x first, and then the numbers we're going to fill in here and here. So if I want to factor x squared plus 7x plus 12, I need numbers that multiply to the constant, which is 12. And I need them to add to the coefficient of x, which is 7. In your homework, there's a space for you to put the number that you want them to multiply to, and the place where you want to put the number that you need them to add to. So 12, I'm going to list some factors of 12. 1 times 12, 2 times 6, 3 times 4. What I want to do is think of those factors of 12 and find the pair that multiplies to 12. They all multiply to 12, and the pair that adds to 7. 7 is 3 times 4. So this is my pair of numbers. I set up my factors, parentheses with an x first in each one, This is positive 3 times positive 4 is 12. Positive 3 plus positive 4 is 7. So I put plus 3 and plus 4. It does not matter whether you put plus 3 and plus 4 or plus 4 and plus 3. The order does not matter. Here are some more examples. Here I have x squared plus 11x plus 30. I need numbers that multiply to 30 and add to 11. Always multiply the constant, add to the coefficient of x. So I think about the factors of 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. And I look down that list until I find a pair that adds up to 11. My factored form is x plus 5 times x plus 6. And again, if you wrote x plus 6 times x plus 5, that would also be correct. Next example, I have positive 56, so I need to multiply to 56, and I need to add, here be careful, I need to add to negative 15. Remember, two positives multiply to a positive and two negatives multiply to a positive, so I'm going to have two negatives that add up to 15. Look at the factors of 56. 1 times 56, 2 times 28, 4 times 14, and 7 times 8. And I'm going to look down there and find the pair that add up to 15. Now, if I want them to add to negative 15, I need negative 7 times negative 8. So when I write my factors, it's going to be x minus 7 and x minus 8. Two more examples. Here I have x squared minus 5x plus 6. I need numbers that multiply to 6 and add to negative 5. Factors of 6, 1 times 6, 2 times 3. I want factors that multiply 6, here they are, and add to negative 5. The pair that adds to 5 is negative 2 times negative 3. In all of these problems, you have to have two positives or two negatives because they're multiplying to a positive. My factors are x minus 2 and x minus 3. Last example, I need numbers that multiply to 36 and add to 12. Factors of 36, there's a lot of them. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. I go down the list and find the pair that adds up to 12. I want them to add to positive 12, so they're both positive. This is x plus 6 times x plus 6. Or, since the factors are the same, you could also write your answer as x plus 6 squared. For today's homework, you're going to fill in what number they need to multiply to, what they need to add to, and then your final answer is your factored form.